Hi friends, welcome to GMK tutorials. In this video, we are going to see about the most important questions in digital logic design. Okay, these 25 questions are very different. Okay, each and every question is very different. Moreover, these questions are very important for end semester point of view, or it may be gate point of view also. Okay. I hope this video definitely helps a lot for you. So in case before starting this video, I have a small request for you. In case ఇప్పటివరకు ఇంకా ఎవరైనా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో సబ్స్క్రైబ్ చేసుకోండి, వీళ్ళకి లైక్ చేయండి అండ్ షేర్ చేయండి. So let us move on to the first question. The decimal 43 in hexadecimal. The decimal 43 in hexadecimal. At the same time, that decimal number is also can be represented in the form of a BCD format. Okay, so let us see the solution for this one. So it is a decimal number. The decimal number can be converted into hexadecimal. So hexadecimal means that obviously this 43 can be divided with 16 format. So 16 twos are 32. So remaining 8 plus 11. Therefore 11 can be represented as a B. Directly represent like this. So here base is 16. At the same time 43 is also can be represented in the form of a BCD format. If you are representing in terms of a 4-bit format, 4 is generally called as 0 1 0 0. At the same time 3 is equal to 0 0 1 1. So by combining these two, it becomes as a BCD number. So this question is also GATE 2005 question. Okay, in the year of 2005, it is also 1 mark question in GATE. Okay, so next one, question number 2. Question number 2. So the present output of Qn of a edge triggered JK flip-flop is logic 0. If J is equal to 1 actually, where if J is equal to 1, then Qn plus 1. So that means they mentioned that JK flip-flop output is equal to 0 present. Okay. At the same time, suppose if the input J is equal to 1, at that time what is this is generally called the Qn. What is the next state? Qn plus 1. At that time obviously it is equal to 1 because when J is equal to 1 and K is equal to 0, when J is equal to 1 means that at that time K is equal to 0. So it means that it is a set condition. In the set condition, obviously the output is set to 1 only. Okay, 1. So the answer for this question is equal to 1. So let us move on to the third question. Let us see just a minute. So this is a question, right? So what is the question? They mentioned that the building block of as shown in figure is an active high decoder. That means they mentioned that some decoder. This decoder is also 3 to 8 decoder because of it consisting of 3 inputs and 8 outputs. Therefore, it is a 3 to 8 decoder, also 3 to 8 line decoder also. Okay. So in this configuration, in this block diagram, they mentioned that 3 inputs A, B, C are the inputs. So they mentioned that what is the value of X. So at that time you have to check the conditions. So obviously the output of the decoder is also called the minterms. Okay. Therefore, this D6 is selected whenever the 3 possible combinations. That is nothing but ABC is nothing but ABC. So 0 0 0, 0 0 1, 0 1 0, 0 11, 1 00, 1 0 1, 110, 111, 0. These are the 8 possible ways. So D6 is nothing but obviously this one. This is D6. So D7 and next one D3, D0. D3 only D3. This is D3. D3, D5. So these are the pauses. So by replacing the corresponding A011 with A bar BC. So like that you have to represent the values, then you will get the solution for this. Okay. Solution for this case. Okay. So that is the answer for this one. Okay. Next question. Next question. So a PLA is realized. It is based on a PLA question. Okay. If suppose a PLA relation is shown in figure. They mentioned that is some diagram actually. So just I will zoom it. That's better, right? So this is designed by PLA, right? PLA. So at the time, the question for this one, what is the question? So they mentioned the PLA realization. So where three inputs X0, X1, X2, and these are the AND gates connected to the corresponding dotted represents the corresponding connection. So for F1 function, what are the connected components? So for F1 is nothing but these product terms are with the help of a OR gate. Therefore, in this case, what is the value here? So this value represents this nothing but dot, where dot is nothing but complement x naught dot x naught bar. At the same time, this dot represents the x2. These two are product. This is a one unproduct. So second one is nothing but this is over, right? So in this line, so three connections are there. So first connection is nothing but x naught, second connection x1 bar, third connection x2 bar. Okay. So at the same time, so these two gates also. So this is the only gate connected to the. So this is also. So we have only. It is not connected actually. So this is a. So that means wherever the star lines are there, that lines can be ORed with the help of a OR gate only. Okay. These two over. Third one is nothing but x2 bar and x0. So x0 into x2 bar. x0 into x2 bar. So from this x0 into x2 bar is common, therefore 1 plus x1 bar is equal to 1. Therefore you will get the output is equal to x1 r or x1 xr with x2, x0 xr with x2. So this is the solution for this case. If you are simplifying this one, you will get the solution like this. So this is a representation. So 1 plus 1, therefore this is a XOR operation. Okay. So next one is nothing but next question number 5. So I will discuss very quickly. So in this case, what is the called? A master slave flip flop has the characteristics that what is the master slave? Master slave. That means whenever the slave changes, at that time only output changes. So that is the answer for this question. So next question number 6. What is the question number 6? A mod 12 counter. The question number 6. A mod 12 counter, the flip-flop has a TPD is equal 60 nanoseconds and NAND gate TPD is also 25 nanoseconds. So they mentioned that propagation delay of the flip-flop at the same time NAND gate also. So the maximum clock frequency formula is nothing but F max is less than or equal to 1 by TPG plus N into TPD, where TPG is nothing but propagation delay of the gate, where N is nothing but number of flip-flops, TPD is nothing but propagation delay of the corresponding flip-flop. Suppose if you go for any flip-flop, obviously it takes four minimum number of gates are say 4 gates only. So one NAND gate is equal to TPD. So in case of the 4 NAND gates realization of the flip-flop, so input is passing through 2 gates. Therefore the TPD is equal to 2 only. So 2 into corresponding propagation delay of the gate. Therefore the TPG is nothing but propagation delay of the NAND gate. So I will mention here place N is equal to number of flip-flops required to mod 12 counter. Obviously it requires a 4 count. 4. Okay, therefore 4 into the propagation delay of the flip-flop. That is nothing but 60 into 10 power minus 9. 60 into 10 power minus 9. Therefore if you are calculating, it becomes as a 3.77. You will get the answer of 3.77 is the corresponding answer for this case. Okay. Okay. So next question is nothing but, so these are the some of the general questions. It may be also very useful for us. So the next one is nothing but, very quickly we will revise the topics. So the multiplier can be used as a many to one switch. Multiplier is also called as a many to one. It is also called as a data selector. Okay. At the same time, next question, decoder can be used as a memory chip to select. Okay, it is used to many to one. At the same time, ninth question is nothing but, what is the condition to avoid the resurround problem in the problem? And the propagation delay of the NAND gate is delta t and the pulse width is t. So what is the formula? So this is also very interesting and important question. So basically, the race around condition concept is existing in case of the JK flip-flop only. Okay, in case of the JK flip-flop only, we are getting the race around condition. Okay, so from this consideration, this is a one clock period. Therefore, this span of one period of one half period is generally called as delta t. Complete time duration can be represented as t only. So this is a condition for avoiding the race around condition. Therefore, delta t is less than 2 times that of tp into less than t, where 2TP is nothing but propagation delay of the two NAND gates. Why? Because in case of the JK flip-flop is also designing with the help of NAND gates or NOR gates. So in case of the NAND gate relation, obviously it takes a 4 NAND gates. Therefore, the time taken by the corresponding signal to traveling from first gate to next gate is nothing but 2 times that of the propagation delay of the NAND gate. Okay, so that's why we need to take a 2 times that of TP only. Okay, so this is a condition for avoiding the race around condition. The reason for this one is nothing but TP is the propagation of the one gate and flip-flop is made up of the four gates. Two signals are two, I mean, the input is passing through the two gates, therefore we need to take 2 TP. That is a very important, guys. Okay, let us move on to the next one. This is a very rapid fire, right? So just I don't want to take much more time for this case also. So the next question is nothing but an N flip-flops ripple counter can count up to the number of states in case of the ripple counter is also called as 2 power n states. So that is also important question, right? So the next one is nothing but very important question. It's a very important and very conceptual question. Okay, let us see here. So the next question is nothing but, initially the corresponding counter is at 0 1 state, 0 Q1 0, Q0 0, Q1 0. At the same time, what will be the logic state of the Q0 and Q0 immediately after the 777th clock pulse? Okay, this is a very important question, guys. Okay, so let us see here. It is actually one kind of a ring counter, right? But it is a ripple counter, but it's a ring counter actually. Okay, ring counter, but it's a Johnson counter because the output of the corresponding complement of the last gate is connected to the input. So that's why it is called a Johnson counter also. Okay, Johnson counter. Johnson counter. Next thing is nothing but, so in case of the Johnson counter, suppose if you observe this case, these are the some of the important conclusions for this problem. Let us see here. In case of the Johnson counter, Q bar is connected to the input. So that's why it is called a Johnson counter. Moreover, in case of the Johnson counter, when the Q bar is connected like that, obviously it is called as a down counter. Therefore, the number of states in case of the Johnson counter is nothing but 2n. So where n is nothing but number of flip-flops in this case. So number of flip-flops in this case is equal to, therefore 2 2s are 4. So in case of after 4 clock pulses, the state is repeated, but it is not in a sequence format in case of the Johnson counter. Therefore, 770 after 776 means 777 after immediately 777 pulse means that 776 is divided with 4. It takes obviously even number, therefore only 0 state only. So 777 means that first state. Therefore, the first state is nothing but 10 is the, so that means 00 next state is nothing but 10 state. Therefore, the output for this case, in case of 777 by 4 is nothing but it takes a remainder of 1. Therefore, zeros to the next one is nothing but 10 state. So that is the output for in this case. So it is very important, guys. Okay. In case they give me any number, not only 774, maybe something they ask 500 also like that. They have to divide it with 4. If it is a 0, then we can state of the corresponding flip flop is counter is equal 0 0 state only. Okay. Now based on the remainder, you can decide the count is incremented by 1 or 2 like this. Okay. Okay. So this is so here also same thing. 0 0 state means that where q1 is equal to 0, q bar is equal to 1. Therefore, next pulse 1 is connected to here. So that's why 1 0 sequence is existing. At the same time, for second case is also same criteria. Okay. So therefore, in the next pulse they will connect it as a 1 1. So therefore, q1 q1 q0 q1 Therefore, the complement of 1 is equal to 0. Therefore, in the next state you will get 0 1. So that is a pattern how we are getting this case. Okay, I think all of you having some basic idea, right? So I don't want to take much more time here also. Okay. So next one is nothing but next important question. So the question number 12. So the next question is nothing but 12th question. They mentioned that the largest a certain JK flip flop has a TPD is 12.5 nanoseconds. Propagation delay of the JK flip flop is 12.5 nanoseconds. The largest mod counter that can be constructed from these flip flops and still operate up to 10 megahertz. So from this given information, you have to identify f is equal to here, f is equal to 10 megahertz. If you know the f, obviously you can calculate the time period. That is nothing but 1 by f. From this you will get a 100 nanoseconds. If you know the number of, that means number of flip flops n is equal to clock period divided by propagation delay of the corresponding flip flop. So from this basic data, propagation delay is equal to 100 nanoseconds from this calculation. At the same time, this is a given data of 12.5. If we calculate it, we'll get 8, right? So this is the answer for this one. So if you know the number of flip flops, obviously the maximum number of states is equal to or mod of the count is equal to 2 power 8. Therefore, 2 power 8 is equal to 256. Therefore, the mod of the counter is equal to 256 only. So that is a very simple answers for these questions also. Okay. So the next question is, guys, question number 13. So next question number 13 is nothing but according to the De Morgan's second law, a NAND gate is equivalent to the bubbled OR gate. Or maybe if you go for any shortcuts also, you will find the same answer because of it is a standard the definition for a NAND gate is equal to the bubbled OR gate. At the same time, if you go for a NOR gate consideration, that is equal to bubbled AND gate. So that is the difference, right? You have to remember that way also. Okay? At the same time, question number 14, in NAND circuits are also equivalent to the AND OR circuits. It is also equal to the AND OR circuits. Next question, that is nothing but what is the frequency of a pulse at a point A, B, C and D in the circuit? So they mentioned that one circuit. In that circuit, they mentioned that one circuit. In that, there is a one diagram is there. Okay. So one diagram is there. At that time, they mentioned some of the important conclusions here. So the input for the circuit is nothing but input for the circuit is 100, right? 100 clock frequency. So the clock is equal to 100 kilohertz. So if you give, if the clock is applied to the first box, that box consisting of a 10-bit ring counter. Is a 10-bit ring counter means that obviously the 10-bit or 5-bit is nothing but that represents the mod value. Suppose if you want to find out the output of the corresponding block, and that is nothing but obviously that input is divided with the corresponding mod value. So therefore, in the first case, 100k divided with 10, therefore we will get 10 kilohertz. That is in the symbol A value. That A is connected to the input to the second one. Therefore, from the input frequency is equal to 10 divided by say mod 20 counter. Therefore, divided with the 20 into 10k, then you will find 500 hertz. The same time, thought consideration is also same thing. 4-bit parallel. But 4-bit parallel means that the parallel consisting of a 4-bit parallel count. So 4 flip flops. Therefore, 2 power n is equal to 16. Therefore, the mod 16, therefore it takes the 500 divided by 16, you will get a 31.25. At the same time, in the last case, 4-bit Johnson counter. The Johnson counter is nothing but where n is equal to 4. The number of states in Johnson counter is 2n, therefore it takes 8 only. Therefore, d is equal to 31.25 divided by 8, then you will get 3.9 hedges. So, this is a solution for the postponing question. Let us move on to the next question. Next question, that is nothing but, this is a very easy question, I think. Okay, everyone can answer this question. Okay, so find the 177 of 8 plus 1 in the decimal. So actually, this 177 is nothing but this octal value. Okay, after octal number. So this octal number can be converted into the decimal format. So that is important. So therefore, you have to follow the procedure: 8 power 0 into 7. 8 power 1 into 7, 8 square into 1. So after all the calculation, you will get a 128. That is nothing but decimal value. Therefore, it can be represented base 10 only. Okay, now. So the next question, that is nothing but the number of Boolean functions that can be generated by n variables is equal to 2 power 2 to n. So therefore, if you are taking a 2 variables, so 2 power 4 is equal to 8 possible Boolean functions can be represented from the corresponding given n variables. So that is a question number 17. Okay, 17. Okay, next question. That is nothing but a ripple counter can count 2 power n states. Therefore, the mod of this one is equal to mod n counter. So Johnson counter is consisting of 2 times that of the corresponding n value. Therefore, number of states. Therefore, 2n. So ring counter is equal to number of states is equal to n. In case of sequence counter, 2 power n minus 1. These are the number of states in case of the corresponding counters. Ring counter 2 power 2n, Johnson counter 2n, ripple counter 2 power n, ring counter n only. At the same time, sequence counter it takes 2n minus 1. Okay. So this is a. So at the same time, question number 22 is nothing but question number 22. That is nothing but a carry look ahead is frequently used because of it is a faster. That is a reason carry look ahead is used in case of the corresponding. Okay. So from this question, then the 23rd question. So from 23rd question, the Hamming codes are used for error detection as well as correction. If the minimum Hamming distance is m, then the number of errors correctable is less than m by 2. So based on the minimum distance, half of the only less than half of that only we can detect under we can detect the correctable. So that is nothing but if the minimum Hamming distance is m, the number of errors correctable is less than m by 2 only. Okay? So that is a మనం తీసుకున్న హాఫ్ లో కంటే తక్కువ ఉన్న మాత్రం ఎర్రర్స్ డిటెక్షన్. The question number 24, that is nothing but a combinational circuit is one in which the output depends on the input only. So I think it's a very easy question. So at the same time, in a sequential circuit, it consisting of the feedback mechanism. So in case of a sequential input and output, at the same time some feedback pattern. Therefore, the output depends on input value as well as the feedback. So that's why it is a feedback is as well as a past value. Therefore, in case of the sequential circuit, the output depends on a past output as well as present input. So these are the 25 questions randomly selected in case of the objective point of view as well as the gate point of view also. So thank you guys. Thank you for watching GMK tutorials. So compulsory session like cheyandi. So if you like this session, definitely I can give more and more videos related to the DLD as per your requirements. Okay. So thank you guys. Thank you for watching GMK tutorials. So 25 questions, 25 minutes. It's a rapid fire. Each question takes almost 1 minute. Maybe some of the questions take less than half minute also. Okay. So thank you guys. Thank you for choosing GMK tutorials.